Hello everyone, thank you for joining my video presentation on understanding the climate change, which is my machine learning project for my machine learning course. So let's discuss on the uh, analysis. So today we are going to delve into the interactive world of climate change analysis. So that topic affects each and every one of us, whether we realize it or not. So let's start by defining what we mean by climate change, especially it refers to the long-term alterations of climate pattern like encompassing shifts in temperature, like precipitations, sea levels, and many more. So it is important to understand that while natural factors have historically influenced the Earth's climate, the rapid pace and then the intensity of contemporary climate change are primarily attributed to human activities, particularly the emission of greenhouse gases. So, our journey today will focus on unraveling the complexities of climate change and exploring how data driven analysis can provide valuable insights into this critical issue. So, let's get deep into it. So, what's the goal of my research is? So, since now we have the basic understanding of what climate change and so let's delve into the goal as you guys will understand. So, our primary objective is to predict and understand various facets of climate change, ranging from its causes and consequences to mitigations and adaptation strategies. So, ultimately, my aim was to produce or provide the insights that can inform decision making process at both local and global levels, which will be helpful for the stakeholders as the audience and then the policymakers and scientists to communities and individuals. Like everyone stands to benefit from a deeper understanding of climate dynamics. So, the data overview. Where did I get the data to fuel my research? So, my dataset was from the reputable sources Berkeley Earth Surface Temperature Study. So, this dataset is incredibly valuable due to its transparency and then the comprehensiveness. So, it allows us to delve deep into climate trends and patterns with confidence. High quality data is the cornerstone of climate analysis, and I'm fortunate to have access to such a robust data set for my research. So here are the insights, the details of my data set. I got it from Kaggle, even though the source was from the Berkeley Institute. They had more than like 10 million rows of data, and then the data files were like around like five five files which had like global land temperatures by cities, by major cities, by states, and then by country, and then it's a separate file for the global temperature as well. So here are the sample data set of the global temperature and then the global land temperature by country. And this data set consists of like 250 years of data. That's a huge data set, as you all might know by now. And then the other data file I had was like by major cities. Here are the sample things I have given you. And then over here, the description has been like the data descriptions given below to identify it easily what the feature means so that it might be helpful for you guys when you look into my website of each and every data analysis. You will get an deep informations and then insights of the how do I say the analysis of the climate global warming things. So, uncovering the insights, which is like interesting findings, getting on to the next part. Through our analysis, it's like I uncovered some fascinating insights that shed lights on the complexities of data change, where I have utilized advanced techniques like decision tree, naive Bayes, and then support vector missions to discern patterns, predict phenomena, and then identify factors influencing climate dynamics. So, from understanding the primary cause of climate change to exploring mitigations and then adaptation strategies, my research offers valuable insights for addressing this present pressing environmental challenge. Like getting into it, I haven't given you too technical details, which might be hard for you guys to understand. If you want to know too much technical and then like want to know what I have done in Decentree, what I have done in iBase, SVM, you can check my website, which is given below in the description for you. You can go there and then read the whole thing, my research, and then my writings about my finds and then the insights, which uh, will be quite interesting as well to know how our world is being changed. So here are the sample things like I would give you like the average land temperature and then average land temperature uncertainty trends over the year. It's like for the uh, over here the line graph displays you the land temperature average thing for from 1750 to 2015. So you can see here that the highest land temperature was recorded in 1761, reaching 19 Celsius as an average, while the lowest temperature was noted in 1768 at minus 2.18 degrees Celsius. Moreover, there is a noticeable decrease observed in the average land temperature uncertainty values over time. This decline suggests improved accuracy or reduced variability in the temperature measurements like throughout the duration. And the next one gives you the average temperature in 2013 by countries. When you see the graph, you could see that like the continents below the equator line has like the highest average temperature, which is like too much uh, for the present state. Like in 2013, all the southern countries of North America, Africa, Oceania, which was earlier Australia, and then the Middle East, Asia, Southeast Asia, which comes like the Japan things and all. And some other part of Central Asia showcase noticeable higher average temperature. As I told you, like they're all below the equator level. And noticeably, the thing is that the entire southern hemisphere displayed average temperature higher than the global average, whereas the northern hemisphere, that's the above equator level, exhibited like comparatively lower average temperature, which includes like US, Canada, Russia, and in the Europe countries as well. So this one is like gives you the temperature content for all seasons like summer, winter, autumn, and then spring. Over here, as you can see the graph that over the course of 250 years, the summer season consistently demonstrate the highest temperature trends, typically ranging from 12 to 19 degrees Celsius. Following this, both autumn and spring exhibits temperature trends within the range of 8 to 11 degrees Celsius. So conversely, the winter season consists displays the lowest temperature trends ranging between 0 to 5 degrees Celsius all over the world. So this is like across a span of 250 years. So all season exhibits a consistent upward trend in temperature. You can see that the temperature is quite being increased when it moves from 1950 to 2000 and above, which gives you the warning of the global warming increase, like what step we need to look into it to prevent that. And this would give you the clear view of how the average land temperature in the world, like from 1750 to 2015, has increased. Like it gives you the evidence that there is a prevailing trend of global warming in recent times. So analyzing it with the data sets taken, it indicates that the average temperature of the Earth's surface has reached its highest point in the past 3 centuries with the most rapid increase over occurring within the last 3 decades. So these findings evoke concerns as the observer hopes for a shift transition towards ecological sources of energy to mitigate carbon dioxide emissions. Failure to adopt such measure could lead to disastrous consequences. So furthermore, inclusion of confidence interval in the chart suggests that an improvement in the accuracy of temperature measurement in the recent years. As you can see that we need to take step to reduce the global warming thing, or else it's going to be too hard to give it to the next future. So shaping the future. As a conclusion, climate change analysis is not just about understanding past and present, it's about shaping the future. So by leveraging the data-driven approaches, we can gain deeper insights into climate dynamics and inform evidence based strategies for mitigations and adaptations. So it's clear that collective action is necessary for the resilient future. So together, we can work towards a more sustainable and equitable world for generations to come. So, this is my presentation on understanding the climate change. Okay, hope you got some deep dive analysis with the insights that I gave. If you want to go and learn more about it, just go through my websites and then you can have like the whole analysis. It's been given in a deeper version over there. So thank you for your all your attentions today. I hope you find my presentation insightful and thoughtful provoking. So yeah, thank you.